Hi guys, welcome to this video. In this video, we shall present the measures of dispersion in the data and show how to calculate the first such measure, which is called range. To understand the importance of the measures of dispersion, let's take an example. Suppose the mean mark of a class is 70%. Now that's a very high average score, right? But does that mean that the whole class did well? I mean, did they do well as a whole? Not necessarily. Let's look at this distribution where it appears that most of the class marks are indeed around 70%. So this class is doing well indeed. But in contrast, here's another distribution where the mean score is still 70, but you can visually see that the marks are spread very widely. The scores are all over the place. So simply looking at the average value is not enough to state the overall the situation in the data. We must factor in the spread of the data as well to understand how diverse the underlying data source is. A small spread means that we can trust that the average value represents the overall data well. But a large spread means we cannot trust the average value that it represents all the data, because the data with a large spread is all over the place. So how can we measure the spread in the data? Well, there are three popular measures of spread or dispersion. These include the range, the interquartile range, and variance and its close cousin, the standard deviation. So let's discuss these measures of dispersion. So in this video, we are going to introduce you to range. The range is computed by subtracting the minimum value of the data from the maximum value in the data. Suppose here's a table of marks for different students. Now to find the range, although it is not necessary, but it helps to order the data first, because then it's simple to find the maximum and minimum, because they lie at the two extremes of the ordered data. So the question is, shall we order the data by the student ID or by marks? Since we are interested in the range of marks, we shall order by marks. So here is the ordered data now. Note, student IDs have been rearranged accordingly as well in the ordered data. Also, I have colored the maximum values at the bottom and the minimum mark at the top, so it's easy for you to see. Now that we have got the ordered data, we don't really need the raw data anymore, so we can ignore that. So the range, as described at the top of the slide, is equal to the maximum mark minus the minimum mark, which equals 4 take away 1, and which equals 3. So the range equals 3. Now, a weakness of range is that it is easily affected by outliers or one extreme value at maximum or minimum. For example, if the maximum score jumps up to 14, I mean, the previous slide, the maximum score was 4. I hope you remember that. But now I've changed that to 14, right at the bottom. Then the range is, again, maximum take away minimum, which in the maximum in this case is 14. So 14 take away 1, and that is 11. Now, this is a significant jump from the last range, which was only 3. So it suggests that the spread in the data is much higher than before, even though most of the data is still the same and most of the data is close together. There's only one exceptional value that exists at the upper extreme. Similarly, if we had an extremely low value, that can also impact the range, and I hope you agree. This leads us to the discussion of the quartiles next, that we shall present in the next video, and we'll see that the quartiles are less susceptible to extreme values or outliers than range. So we'll see you in the next video.